Okay, so we're going to look at this particular proof. We're starting to prove that triangles are congruent. So what I'm going to do is I'm going to look at these proofs here. And this first one I'm going to do, we're given that C is the midpoint of BD and that C is the midpoint of AE, and told to prove that triangle ABC is congruent to triangle EDC. So first of all we always do is we state the givens first. Now remember, I told you have the option of putting the givens first if you wish, and you can put them all together or you can spread them out. I'm going to go ahead and spread the givens out in this particular example, and I'll show you why, and you'll see it in just a second. So let me change the orientation here. We got a little bit of a shadow. Okay, so the first statement is going to be, I'm going to choose one of my givens. So I'm going to use C as the midpoint of BD. All right, so C is the midpoint of BD. Okay, and I know that because it's given. Okay, so I'm going to put that, I'm just going to use one given right now. This one right here. Okay, so if C is the midpoint of BD, that is key. That tells us something. So if you look at this, C is the midpoint of BD. What does that tell us about BC and CD? If C is right in the middle, that means BC and CD must be congruent to each other. So, because of the definition of midpoint, I can say BC is congruent to CD by the definition of midpoint. And you'll just write, there is no postulate, so it's just the definition of midpoint. So as you can see, all I've done is mark these two sides congruent based on what I knew about midpoint. So there's really nowhere else I can go with these two, with this one. Remember, you're going from here to here. How did I get from here to here? So let's put the next given in. Let's go up and put our next given is. And I'm going to start putting the givens in blue so we can see them. So C is the midpoint of AE. That's also given to you. And that's also given. Okay? So the question is, what am I going to do with this particular information? Well, knowing that C is also the midpoint of AE, doesn't that mean C's in the middle, so that AC would be the same length as CE? So now, based on this given information, I can say that AC is congruent to CE by also the definition of midpoint. Okay? And remember, when we try to prove triangles congruent, we're basically, if we use any of our theorems and postulates, we're trying to prove three pieces of information. We don't have to show that all three angles and all three sides are congruent. We can just show three pieces. That's enough. So we can either do angles and sides, or we can do an angle and two sides, or two angles and a side, two sides and an angle, three sides. Now remember, it depends on the sequence. Remember your favorite thing, there's no ass, the donkey theorem. There is no ass in geometry. You cannot use angle side side or SSA. And there's no AAA. Those don't prove congruence. So let's move on and let's see what we can get next. And I've got my two sides here. So do I see anything else? There are no more givens. So I have to kind of infer from the picture what else I could possibly use. Well, one of our favorite things I see here is I see these two angles. I see a pair of vertical angles. So I can state that those two angles are the same because they're vertical. Now, if you remember, I can't just say angle C. I can't just use the vertex because there's four different angles here attached to that vertex, so I have to be specific. So I'm going to call this one BCA. You could also call it ACB as long as the C's in the middle. And I know that's congruent to DCE, which you could also call ECD if you wanted to. And that's by the vertical angle theorem. Or, I'm going to start letting you guys write this out. If you want to, you could just write vertical angles are congruent. If you can't remember the theorem name, just write that out. Okay, so now, boys and girls, look at what we have. We have two triangles here. and we've got one side that matches up, a second side that matches up, and an angle included, remember that word included, between the two of them in the same order. 1 slash, 1 arc, 2 slashes. 1 slash, 1 arc, 2 slashes. So I have now successfully proven that triangle ABC is congruent to triangle EDC by side, angle, side. This is the side, angle, side theorem. Side, angle, side. So this is just one example of how you can prove side, angle, side. I now know that the triangles are completely congruent because I was able to establish a side, angle, side pattern between the two of them. So now if I wanted to, I could go on to say now that I know that angle A must be the same as angle E, B must be the same as D, and BA must be congruent to ED. And I only know that now because I just established the congruence. So that's one example of how you prove with side, angle, side.